Hi everyone, in this we are going to learn about the leading zero detector and understand how it works using a binary search approach. A leading zero detector is a combinational circuit that counts the number of consecutive zeros starting from the MSB until the first logic one is encountered. For example, if we have a 32-bit input and the bit pattern starts with 5 zeros before the first one, then the output of the leading zero detector will be 5. Now, the straightforward approach would be to examine every bit one by one starting from the MSB. However, for large word sizes such as 32-bit or 64 bits, this approach can become slow. Therefore, to improve the speed, we use a binary search-based technique. Now, let's see how this works for a 32-bit input. We begin by dividing the input into two halves. Let the input be x31 down to 0. Therefore, the upper half is x31 down to 16 and the lower half is x15 down to 0. In the first step, we check whether the upper 16 bit, which is x31 down to 16, are all zeros. If it is equal to 0, it means that the first logic 1 cannot be present in this region. Therefore, we already know that there are at least 16 leading zeros. So we add 16 to the leading zero count and continue our search only in the lower 16 bit, which is x15 down to 0. On the other hand, if x31 down to 16 is not 0, then the first logic 1 must be present somewhere within these upper 16 bits. In this case, we ignore the lower half and continue searching only in x31 down to 16. Next, we apply the same idea to the selected 16-bit block. We divide it into 8-bit blocks and check whether the upper bits are all zeros. If they are all zeros, we add 8 more to the count and continue searching in the lower 8-bit. Otherwise, we continue searching in the upper 8-bit. Again, we repeat the same process. We check a 4-bit block. If the upper 4 bits are 0, we add 4 to the count. Then we move to a 2-bit block. If the upper 2 bits are 0, we add 2 to the count. Finally, we check the remaining single bit. If that bit is 0, we add 1 to the count. By repeatedly dividing the search space into two equal parts, we can quickly locate the first logic 1 and determine the total number of leading zeros. This method is called binary search based leading zero detector because at every stage the search area is reduced by half. The main advantage of this approach is that it significantly reduces the delay compared to checking all 32 bits sequentially. Because of its high speed, the leading zero detector is widely used in high performance processors. I hope this video helped to understand the working principle of a leading zero detector using binary search. Thank you for watching and see you in the next video.